Performing masked aggregations in PyTorch efficiently. Introduction. When working with tensor data in PyTorch, it's common to need aggregations, mean, max, min, etc., over subsets of data defined by a mask. For example, ignoring padding or invalid values in batched sequences. This post clarifies how to perform these masked aggregations in a clean and efficient way using modern PyTorch features. The problem. Given an input tensor x and a Boolean masked tensor mask, how do we compute aggregations over only the valid, i.e., true and mask, elements? Example tensors. The goal is to compute masked means, sums, maxima, minima, etc., considering only elements where the mask is true. Common but manual approach. A straightforward approach involves multiplying x by the mask, after converting mask to the tensor's type, to zero out invalid entries. Summing the masked values. Dividing by the count of valid values per row, or appropriate dimension. Example for masked mean. While this works, it requires manual bookkeeping and can be error-prone for other reductions. PyTorch's modern way, using scatter_reduce. PyTorch introduced scatter_reduce as a flexible operation to scatter values with reduction operations like sum, prod, mean, amax, amean. We can leverage this to perform masked aggregations cleanly. How does this work? Extract the indices where the mask is true. Use scatter_reduce to aggregate values from x at those indices into an output tensor. Example. Output. Notes and recommendations. Convert x to a floating point type when doing mean or prod to avoid integer division issues. Scatter_reduce works efficiently for various reduction methods beyond sum and mean. Avoid torch.masked as it's still in prototype and may not be stable. Summary. Performing masked aggregations in PyTorch can be done manually or with newer functions like scatter_reduce. Manual masked aggregation requires zeroing out unwanted values and normalizing. Scatter_reduce offers a flexible, built-in way to aggregate values at indices defined by masks. This approach is efficient, clean, and leverages PyTorch's latest APIs for common masked operations. Happy tensor aggregating!